Problem number 10. Which of these is the most polar bond? CCl, CO, NF, NS, or SiO? Okay, so let me jot these down real quick. CCl, CO, NF, NS, I keep losing my place, and SiO. Okay, so when we talk about polarity, the biggest thing that we're looking for is the polarity of a bond. The biggest thing that we're looking for is the difference in electronegativity of one thing on the bond to the other thing on the bond. So for example, the difference in the electronegativity of C versus the electronegativity of Cl. And the biggest difference is going to be the most polar bond. Okay? So remember, I've drawn part of the periodic table here once again. So remember that electronegativity generally increases to the right and up on the periodic table. Now this doesn't apply to the noble gases like helium, neon, and argon, but for everything else, that's a pretty safe bet. So let's take a look at the first one. C to Cl. Carbon, you go over 3 and down 1. So that's probably going to be an increase in electronegativity, but keep in mind that you do go over and then down. Okay? For carbon to oxygen, this is also going to be an increase in electronegativity because you're going to the right. However, you don't change. So this is basically, that's good because it's going to the right. This one's not so good because you do go to the right, but then you go down, which is not what we want. The biggest difference in electronegativity is going to be something where the change is to the right and then up. So N to F, start here, you go to F, that's also over. N to S, go over and then down 1. So that could, so you're increasing the electronegativity, but then you're decreasing it by going down. So it could still be polar. This last one, Si to O, you go over 2 and then up 1. So here you see the change on the periodic table corresponds exactly to our electronegativity trend. So this is going to be your answer. The difference in electronegativity between silicon and oxygen is going to make the most polar bond. And that is choice 5 on your test.